Hello everyone. So let's see how to solve today's question. So today's question is zero array transformation 4. So in this question what we are given is that you are given an integer array nums of length n and a 2D array queries where queries I is equals to li, ri and val I. Each query I represent the following action on nums. So what the action is, select a subset of indices in the range li to ri from nums. So whatever query which we are currently looking at, in that what we can do is we can select any subset of this li ri, and then what we have to do is decrement the value at each selected index by exactly val I. Then a zero array is an array with all its element equals to 0. Return the minimum possible non-negative value of k such that after processing the first k queries in sequence, nums become a zero array. If no such k exists, return -1. So what this question is saying, we have to find the minimum non-negative value of k such that when we select the first k query, so suppose if in this case, if we see, if we select the first two queries, then our requirement is getting satisfied. What is the requirement? The requirement is to create the zero array. So if we can convert all of these elements to zero by doing these operations, which we are given over here, by selecting some queries from it, and that should be ideally the minimum number of queries in a sequence. So what we can do is we can select all of them three, like all the three at the worst case. We can select the first two, or we can select only one also. So we have to select them in sequence. Either we select this, either we select this, or we select all of them. But we have to select the minimum query such that we are able to make this nums array equal to 0, like all of these elements should be 0 by doing these operations. Okay, so let's see the example and let's try to understand the question a bit more. So if you see this example, what is given in this is, if we choose the first query, so the output is 2. So what they are saying is, if we just select the first two queries, then we can make this whole nums array to 0 by doing this operations. Okay, so let's see how they have done the operations. So when they selected this first query 0 to 2, they selected the indexes 0 and 2 only. So this index, and they decremented the value by 1. Okay, so then what the array became is this 101. Then what did they? Then they selected this second query, and in the second query, then they again selected this subset, this 0 and this 1, and then they decremented it. So then the array became triple zero. So it satisfies our condition. So we can say we are able to make zero array with just the first two queries. So if you try to see, like if we take all of them three, so obviously we'll be able to make them zero. But if you take just the first one, then no matter what you do, you won't be able to make this whole array zero, because if we just select this, then we can decrement these both by 1 unit only. So this can be at best this, but we have to create this. So for this we need at least two. Okay, so if no such k exists, then also we have to return -1, which means if by selecting even all of them, if we are not able to convert this to 0, then we have to return a -1. So if you see in this example, the range is from 1 to 3, 1 to 3, and we can decrement these values by 2. Okay, so if you select all of these values to be decremented by 2, then also you are given like this 0 to 2. From this also you can select a subset and decrement these values by 1. Okay, so suppose if you take this one, okay, 0 to 2, and you decrement these values by 1. Okay, so then what will it become? It will become like 3, it will become 2, it will become 1. Okay, if you select all of them. Okay, and then if you select like 1 to 3 ranges given, and we have to decrement these values by 2. then if you select this value to be decremented by 2, this becomes 0. Then we cannot decrement this value by 2, this we cannot make this decrement by 2. So we cannot make this whole 0. So if whatever you try to do, you won't be able to make all of them 0, okay? Because we have to use a query only once. We can use this query only once, and we have to decrement this value exactly by this value, and we have to make this 0. So in this case you won't be able to make it 0, so that's why you have to return a -1. Okay, so I hope you was able to understand the question. So now let's see how to approach this question. So if you see what is given to us, we have to return the minimum possible non-negative value of k. Minimum. Okay, so when I think minimum, like some things come to my mind. One of them is binary search. One of them is DP. Okay, so these two comes first into my mind. So if, and also if you see in this question like how it's framed, so see, if you select, suppose your answer is able to be generated from, let's say, 0, 1, 2, 3. So let's say you were able to make your array 0 by just using this this four queries. Okay, so if you select any number of queries after that, okay, so if you were able to make the answer from the first four, then no matter what, if you choose even 5, if you choose 6, if you choose 7, if you choose 8, you will be able to make the answer, right? And suppose if 4 was your answer, then no matter what you select, if you select 3, if you select 2, if you select 1, you won't be able to make. Okay, so you see there's a nice separation over here. See, like there's a this a partition, and from over here we have to select the first value which is giving us the answer. So if you are able to recognize this form, so this first value we need to find, and this is just a binary search question then. Okay. So what we will do, our answer range can lie from like 0, like if we don't choose any value and if we are able to make the whole array 0, and the max can be the number of queries given to us. We can select all the queries and we can make it 0. So our answer will lie in this range only, and then I can do a binary search whether if I'm able to do, if I'm able to make the answer in this middle, then what I will do, I'll check before it, like if I'm able to make the answer over here, then it's for sure like I'll be able to make a answer after this also. Okay, so I'll check before this, and if I am able to make a answer over here before this also, then I'll try to reduce it more down to the left side. Okay, so see, that's how we can apply binary search over here. Okay, so now this one thing we have come up with. Okay, we can apply binary search, but if you think like binary search is fine, but then how will our binary search work? Okay, so for any given, like, so if I take a middle in my binary search, and if I say, suppose if I'm selecting the first two queries, then I need to know like whether I can make my array 0 by just using this first two queries. Now my question reduced down to this. Okay, like given like k number of queries, k queries, can you make your array 0? Okay, array 0, can you make it 0? So how to check that? Now to check that, what we can use is, like, suppose for each element, what we will do, we will go to each element and see, like, for this element, if I'm using the first two queries, which by the way, which just means I'm just using these values to make it 0. Okay, so if suppose if this index is a is can be utilized with this range, then I'll consider this in index. Okay, and if suppose this in index is also can be utilized with this range, then I also use this. Okay, so what I'm searching for is by using some queries, can I make this element zero? And this I'll do for all of the elements. Okay, this I'll do for all of the element, and if and I'll check like whether I'm able to make this element zero, whether I'm able to make this element zero, whether I'm able to make this element zero using the current middle number of queries, if you say middle number of queries. Okay, so how I will frame this? We can use DP over here. Okay, okay. Why DP? Because this is essentially breaking it down to like whether if I select this query on this element or not. So if this range and this range is can be utilized for this element, then essentially for each of this query I can decide to utilize this or not utilize this, which is kind of saying like pick or not pick. So if you have done some number of DP questions, this is a very basic form, which is like a knapsack form, and which in which we decide like whether we can take this element or we should not take this element to make our answer. So when I will not take this element, then I will not reduce it down, then I will not reduce this element down. Okay, and if I take this element, then I will reduce it down with this. Okay, so this is the rough idea which we'll be doing. So what we have essentially come up with is we'll be applying binary search because our answer can lie from 0 to like the q number of queries, and for each middle we will check whether we can make our array 0 by using this middle number of queries, and if we can make this answer, then we will reduce it down with the binary search. And then but how we will check for each of this, like whether if we are able to make this with this middle number of queries is using DP. We will be using the knapsack style approach over here, whether if I choose this, and can I make this element 0, if I choose or not choose this, can I make it 0. So after choosing from all of these, can I make this element 0, then I'll check the same thing for this, then I'll check the same thing for this. Okay, so that's a rough idea. When we will see the code just now, then it will make things more clear. Okay, so let's see what I have done over here. What I've done over here is I have just done the binary search. In the binary search, what I have done is I have taken the minimum number of queries which I need to take is 0. Okay, so suppose if in the array the element is 0 only. Okay, then I don't need like anything to make this 0. So I can use 0 number of queries to make this nums 0. Okay, so my minimum can be 0. What can be my maximum value? That is queries.length, because essentially what I can do is I can use all of the values in my queries, and I can make my nums 0 in the worst case. Okay, so between this my answer will lie, and then if this is I have done like I will populate my answer in this answer variable, and by default I have taken this -1, because if we are not able to find the answer, then we will return this -1. Okay, so this is just binary search. Then if it is possible, then what I have done, I have stored this possible answer in my mid. Then I have reduced my end to mid -1. If I'm able to make my answer in this, then I will reduce my search space down to over here, or else I'll reduce my search space down to over here. Okay, that's just what I have done over here. Then the main part lies in this function. Let's see what I've done in this function. So what I've done in this function is I've taken the nums array, I've taken the queries, I've taken my k. So this k is nothing but my mid. Okay, this is nothing but my mid, which I have passed over here. So what I've done, I'll check for all of the nums from 0 to n, whether I can make that num 0 using this first k queries. Okay, so then I have created this valid reductions array. Okay, so why I have done this? So suppose in this, so this index I am looking at. Okay, so this index can be reduced down with only those queries where this is in the query range. Okay, so see, if the index is greater than equals to my query start, and the index is less than equals to my query end. So if my index lies between the left and right of my query, then only I can use this query for my current index, right? So I have taken only those queries which are valid for this current element, okay, over here. So for this current element, whatever the queries which are valid, I have considered them, and in that queries also I have just taken the reduction. Okay, so if I'm able to use this query, suppose this query X, then that query's reduction I have taken in this valid reductions. Okay, so I can reduce this element down with this. Okay, so once I have this like valid reductions with me, so whatever reductions I can make on this nums, what I have done is I have just taken this DP array. This is nothing but DP. Okay, this DP is of Boolean type. In that, what I have initialized it with valid reductions dot size and the number plus one. Because what I'll be doing is I'll be iterating on the index of this valid reductions. So that's why I have taken the valid reductions dot size, and I'll be iterating on, so I'll be basically reducing this number down to zero. From number to zero, I'll be reducing it down. So I'll need this much amount of space in my array, 2D array. So I have taken the num over here. Okay, so for each element, I have done what? I have checked if I'm able to make it zero or not. If it is possible to make zero or not, this current element, can I make it zero by using the reductions currently available to us in this K. So the first K reductions I can use, and that to the valid ones. And can I make this number zero using those reductions? If I'm not able to make this reduction zero, so not the reductions, if I'm not able to make this number zero, then what I will do is I will just return the false over here. So I'll return false. So I hope this part is also clear. Okay, now the main logic of DP lies in this function possible to make zero. So let's see. So before that, if in this whole array, if all of the elements satisfied my condition, then I can just return true over here. Just that. And now let's see like how I have done this check of whether we can make this zero or not, this current element using DP. Okay, so so let's see. Index I have taken target. This target is nothing but my current element. This valid reductions I have passed, like whatever reduction I can make on this number. Or so okay, so if the target is zero, then essentially what I can just say, I can just return zero. So that means I am able to make this current element zero. Okay, so if I reach down to the target zero, then I can make this element to zero. But if the target was not zero, and if I have exhausted my search space, or if the target has been reduced down to less than zero, then in this both case I have just written false from here, because I won't be able to make the number zero. Okay, in this case, then this is just the DP check. If I have already computed the answer for this state, then I will just directly return. Or else what I have done, I have taken the reduction based on this index, what reduction I can make in this number, and I have two choices whether to make this reduction or not make this reduction. So if I make this reduction, then my target gets reduced down by this subtract num, which is basically the reduction, and my index move forward. Okay, so if I can make this zero by this, or I can make this zero by not choosing this. Okay, the choice is not to choose this. And then if out of this any two cases, if I am able to make this element zero, then I will store it in the DP array and just return from over here. So that's how I have checked for each of the element how to make it zero, like if I am able to make it zero or not. Okay, so that part is also done. So yeah, I hope I was able to make you understand this. Now let's just see the final space complexity and time complexity. So space complexity is what? The number of queries times the maximum, which I'm over here. Okay, so if you see this DP array, this DP array is nothing but the number of queries in the worst case. I can take all of the queries over here, and this can be the maximum number, okay, out of all the numbers, whatever the maximum number is. Okay, so this is my space complexity, and in this is space complexity, this will be considered also, like this is being considered, but due to this being small in comparison to this, I have just taken this. Okay, okay, so if you want to add a plus, then you can add a plus order of q also. Okay, order of q. Okay, so that you can do with this order of q also you can add. Okay, after that the time complexity is what? Time complexity is just size of queries, which is q, size of nums, which is n if we have considered, then log q for the binary search part. Then for each element, what I am doing, I am making a DP call and checking for this is for each element. This is for the DP. So DP is state was the number of queries and the max number. So if you want to see like whether this whether this will pass our test cases, so the time complexity should be up till this, just this 10 to the power 8 operations which we should be doing. So if you see and put the values over here, so you will see like we are doing approximately 10 to the power 8 operations only. So this will be passed, and yeah, we can submit this. So yeah, I hope I was able to make you understand this solution, and I was able to make you understand the intuition. So yeah, that's about it for this question. Hope to see you again in the next question. Thank you.